and welcome back. Today we are starting on inverse functions. We will split this into three parts. The first part will simply to understand the idea or the concept of the inverse of a function. The second thing we'll do will be to try to find the inverse of functions using an algebraic approach. And thirdly, we will use a more practical way of seeing this, and that is the graphical perspective of looking at inverse functions. Okay, so let's start with the first bit, which is just to have an idea of the concept of inverse functions. Yeah. Okay. Now, an operation, as many of us will know, I think from elementary school, we start with a basic mathematical operation. Many of us will know what we mean by PEMDAS, parentheses, exponents, multiplication, division, addition, and subtraction. Others have referred to it as BEDMAS or BEMDAS, okay, meaning the same thing. B for brackets, the rest meaning the same. If you come from my neck of the woods, then you probably refer to this as BODMAS. Again, the O, they are referring to of, which is the same thing as an exponent. The order of, not of, but the order of an operation, all right? The order of an operation is the equivalent of exponent, right? So when we say x power n, then n is the order of that operation. One area where we use the order of operation is when we refer to polynomial functions. So when we write x power n, so when we write f of x is ax power n, the n refers to the order or the degree of the polynomial. So the O here refers to the order of an operation, which is the equivalent of an exponent. Right. So most of us will already be familiar with that. So what is an operation? A mathematical operation is the equivalent of a direction or a command, a mathematical command, which would mean like saying add 3 to a number, okay? So when we say add 3, we are adding 3 to something. That something we are adding 3 to will usually be represented by a variable, a letter x or y or z. Okay, so when we say add 3, then that's equivalent to saying x plus 3 or y plus 3 or p plus 3. So a variable that we represent using a letter, we'll use that and add 3 to it. So this is an example of a command or a mathematical command, and this will be referred to as the addition operator, okay, or the addition operation, okay? All right. Other examples of operations, I think we could represent this on our function machine. Let's start our machine there. So when we say x plus 3, here is a machine that is using the operator addition of 3. So in this operator or command, the machine says that whatever we bring in, we will add 3 to it to find a result out there. Okay, so for example, if we add a 2, if we put a 2 into the machine adds the command from the machine says to add 3 to whatever it is that you bring in. So what we are bringing in represents the x. And so when we add 3, we expect to get a 5 out on the other side. Okay? Similarly, if we add a 2, a negative 2 there, the machine will add 3 to negative 2, and we expect to get 1 on the output. Okay? Similarly, if we add 0, put 0 in there, the machine adds 3 to it, and we expect to get a 3 on the other side. Okay? One more, let's see. If we have k minus 3 and we plug in k minus 3, the machine adds 3 to it, and we expect to get a k. So this is what the command add 3 does, or the command add 3, a machine that uses the command of adding 3, that is what it really does, okay? So this is what we might mean by a mathematical operation, okay? A command that tells us to do something to an input in order to get an output, okay? Other commands that we might use might be things like take 3 less, which would be the equivalent of a subtraction operator. All right, and that is represented like that. It could be something like find the square root of, and that would be the square root operator. That would be expressed as the square root of x. So we find the square root of some variable x. All right, I think I have a last one there, and that is he is twice as fast as his sister. Twice that there means multiply by 2. Okay, so that is a multiplication operator represented as such. Okay, all right. Every operator, so here are some examples of operators that we use in mathematics. The basic operators, some of which we've already talked about, are addition, subtraction, multiplication, division, the square, exponential, square root, and so on. But there are also other more advanced operators that you may or may not know, including logarithmic operator, the derivative operator, the integral operator. Cube root should be very, very familiar. Trigonometric will be familiar to some, but not all, and so on. The modulus or absolute function or operator is also another mathematical command that we use daily. Okay? Well, if you've not gone into calculus, you probably will not know about the derivative and integral. If you've not done logarithms, you will not know about the logarithmic operator. If you've not gone into trigonometry, then again, this becomes a little unfamiliar, but that is okay until you will have covered this. Yes? All right, let's talk about the inverse operation. Now, every mathematical operator, as the ones we've talked about up here, each of these operators has what we refer to as an inverse operator or an inverse operation. What is an inverse operation? An inverse operation would be an operation that does the exact opposite of the operation that we have. So an addition operator will have an operator that does the exact opposite. Addition, if we say add 3, then the exact opposite of that would be subtract 3. Okay? So by definition, we'd say a command with the exact opposite effect as the operator or as the original command would be the inverse operator or inverse command. Here is our machine one more time. So if we have an operator which is addition of 3, we know that when we put a number like 2, we expect to get 5. All right? If we put 2, we get 5 on the output. If we put minus 2, we expect to get a 1. So the inverse operator should be, so if we put negative 2, we get a 1. The inverse operator must be the reverse process such that if we put a 1 from that side, we must get a negative 2 on the top side. Okay? Another example, if we put 0 in there, we should get a 3 at the bottom. So the inverse operator should be the expression here or the command here such that if I feed in 3 from this side, I get 0 on the other side. You may pause the video and think about which operator that is, but of course we've already talked about this and we know that that would be the subtraction operator, okay, x minus 3, so that if we put 5, then we have 5 minus 3, we expect to get 2 on the top side, okay? Similarly, if we put 1, then we should have 1 minus 3, so that should give us negative 2, which is what we had put here to get 1 in the first place. So therefore, x plus 3, if x plus 3 is an operator, then the inverse operator would be x minus 3. When we express an operator in terms of a variable like this, we refer to it as function, in which case this is the function and this is the inverse function. Okay, I've already skipped a number of steps, but let's get in there. I will skip additional numbers. 3 gives me 0, as we had said. If I put in k, then I should get k minus 3, like that. Okay, let's see. So then the inverse operator, we can define an inverse operator then. So the inverse of an operation A. So if A is some operation like the x plus 3 that we had earlier, if x is an operation, then an operation with the exact opposite effect as A is referred to as the inverse operation, and we denote the inverse operation with A power negative 1. Now you need to know that A power minus 1 does not mean the same thing as 1 over A. In other words, this is not referring to a negative exponent, okay? So that's just a symbol. Unfortunately, that this was the symbol that these guys came up with, mathematicians came up with. But you must know that when we are referring to inverse functions or inverse operations, then the negative 1 there does not imply 1 over A. Okay, so we are trying to say that the bozo there is telling you that A power minus 1 does not mean the same thing as 1 over A. It's not the reciprocal of A. Okay, so that's just a symbol that is used in mathematics to represent the inverse of a function. It's unfortunate because it confuses students with the exponent of minus 1, which would normally mean 1 over A. All right, here are some functions and their inverses. Most of them you will know. Addition, if an addition is an operation, then the inverse operation is subtraction. Similarly, if subtraction is our operation, then the inverse of subtraction would be addition. Okay? Multiplication, the inverse of multiplication is division. So multiplication and division are inverses of one another. Okay? Square goes with square root. All right? Exponential goes with logarithmic. And again, I've put stars there to indicate that if you have not gone through logarithmic functions or laws of logarithms and exponents and stuff like that, then you don't need to worry about that. You can wait until that has been done, and in which case you will remember that exponents and logarithms are inverses of each other. Okay? Similarly, as we said earlier, an integral is the inverse function of a derivative. Okay? So the process of finding a derivative is the inverse process to that of finding the integral of an expression. All right? Last there is the cube and the cube root. This is not exhaustive. There are very, very many other types of functions or operations and their inverses. Let's move on. Okay. So the inverse function. So we've been talking about inverse operation. Let's now talk about the inverse function. If an operation is expressed in terms of a variable, like x plus 3, like I said earlier, then such an operation is referred to as a function. So, for example, if a function f of x is given by f of x is x plus 3, then we refer to this as the function. Then the inverse function would be referred to as with that same expression, f power negative 1 of x. So this refers to the inverse. It does not refer to 1 over f. Okay? So the inverse of x plus 3 is x minus 3. Okay? So consequently, we can define the inverse function as the function that has the exact opposite effect as f. So f inverse is the function that has the opposite effect of the function f. So x minus 3 is the function which has exactly the opposite effect as x plus 3 there. Okay? I believe we have some examples now. So suppose f of x is a half. What is the expression for the inverse function as given? So clearly, we look at what we have done to our variable x. We are taking a half of x. In other words, we are taking x and dividing by 2. So the operator being used there is division. So the inverse of division is multiplication. And if we are dividing by 2, then we must now multiply by 2 to get the inverse function. And therefore, the inverse function, f inverse, we can write f inverse of x must be 2x. Multiplication being the inverse of division. Okay, so since we are dividing by 2, we must multiply by 2 to get the inverse of that function there. And it makes sense because let x be 4. If x is 4, then a half x is giving us 2. So if x is 4, suppose that x is 4, then it means f of 4 is 2. So we want a function that will take 2. If we put in 2, we should get back 4. Okay? So if I take my 2 and put into this function here and multiply, I will get 4. So clearly this is the inverse of our original function, like that. Okay? In some cases, it's straightforward looking for the inverse. We can tell the inverse by just looking and interpreting offhand. But in some cases, we have to go through an algebraic process, and we will be going into that in the next video. But let's just take a look at another one. Okay, so if we put in 2, we expect to get a 1, all right? If we put -2, we expect to get -1 because half of -2 is -1. So the inverse must be the number such that if we put -1 there, we will get -2 on the other side, and that requires us to, so if we put a 0, we should end up with a 0. So the inverse should give us the opposite values just like that, so we'll not waste any additional time. That should give us a 3. All right, so let's look at an inverse that does the same. Okay, so if we are to get the opposite of what we had earlier, what must be the inverse function? If we put 2, if we put 1, we want to be able to get a 2 on the opposite side. And if we put, if we put 1, we get 2. And if we place -1, we want to be able to get -2 on the opposite side, like that. So we want to get the exact opposite of what we had. If we put a 0 there, we expect to get a 0 because we had put a 0 to get that, I believe. So if we put 0, we get a 0. So what function is it that will do that? And we've already shown what it is. That function needs to be 2x, as we have shown. Okay? So the function is 2x. So if a function is given by a half x, then the inverse function has to be 2x. Okay. Here are other functions and their inverses. So if a function is x power 3, then the inverse function is going to be the cube root of x. All right? That is easy to see because the inverse of a cube is the cube root. But sometimes there are 2 operations. So for example, you can see that here there is a multiplication. So it's 3 times 2 times x. And then there is also a -1. So there is a multiplication and there is a subtraction. So when 2 operations are involved, then we have to use PEMDAS or the BODMAS. We have to think about PEMDAS or BODMAS. So there is multiplication here and there is subtraction. So in PEMDAS, which one comes first? We have to think like that. So in our PEMDAS, multiplication certainly comes before subtraction. Okay? And we should know now that, I think I've placed this in the wrong place. So when we have this scenario, the operation that comes last. So here, multiplication must come before subtraction. So subtraction is the operation that comes last. So when you're looking for the inverse, the operation that comes last must be the operation that you start with. So it's like the reverse process. It's the same process that we use when we are looking for a subject of formula. When we are changing the subject of a formula, then we use PEMDAS in the reverse process. Okay? So when we look at this, the operation that comes last must be minus because multiplication comes before subtraction. And therefore, when we want to find the inverse, we start with the inverse of subtraction. So we take our value of x, and we look for the inverse of that last one, which is negative. So we add 1, and then we go to the multiplication by 3, and the inverse of multiplication by 3 is division by 3, so we take the whole thing and divide by 3. Okay, you can put divide by 3 here or write a third of that, and this is therefore the inverse of 3x minus 1. This is how we find the inverse by just looking. But if you can't see it directly, not to worry. There is an algebraic approach, a mechanism, an algebraic process that helps you find the inverse very readily. Okay, so don't worry about this. Right. So let's move on. Finding how to find the inverse function of head, that is without the algebraic process that we will be looking at in the second video, in the next video. Example, state the inverse function for each of the following. So what's the inverse of x for x? So this should be straightforward. There is only one operation, and that is multiplication by 4, and so the inverse has to be division by 4. So the inverse of that is x divided by 4, or a quarter of x. Okay? Number 2, what is the inverse of 2x minus 1? All right, and now we remember the rule I was talking about, that the last operation to be performed on x comes first when determining the inverse. So we have multiplication by 2, and we have subtraction of 1. So multiplication in PEMDAS, multiplication comes before subtraction, and therefore subtraction is the last operation in this process, so it becomes the first operation in the reverse process, or in the inverse process. We write that our inverse is going to be x, so we take x, but now we add, because the reverse of subtraction is addition. So we'll have x plus 1, and because that one there is multiplied, now we divide by 2. So it's basically x plus 1 divided by 2. Okay? Pretty straightforward. So the inverse of 2x minus 1 is a half into x plus 1. All right, here is a third one. F of x is the square root of x plus 2. Sometimes you may not see this clearly, so another way of writing square root is putting the power of a half, like that. And when you see that, now you think about PEMDAS. When you think about PEMDAS, in PEMDAS, okay, parenthesis comes before order or exponent. So because of that, parenthesis comes before order. So because of that, we must start with order or exponent. Okay? Parenthesis comes before exponent or so-called order in BODMAS. All right? And because of that, we start with the operation that comes last. The operation that comes last is exponent. Our exponent is a half there. So if we are taking power half, what we want to do is to square. So the opposite of square root, or the reverse of square root, or the inverse of square root is the square. So that means we take our value of x and we square. So we take our unknown and we square it. And x here, now we go inside the parenthesis, and it is x plus 2, and the reverse of plus is minus, and so we say minus 2. And this is the inverse of this function. Okay, pretty straightforward if you look at it carefully and you remember the rule that we've talked about. It's the reverse of PEMDAS, or the reverse of BODMAS or BADMAS. Okay, and so the answer to this one is x squared minus 2. Okay, here are a few questions I want you to try without any algebraic processing. Please try to find the inverses of the functions that are that I have given here. There are only 4. We will be meeting additional inverse function. We'll also try to look at how to find those inverses through an algebraic process. Okay, I believe this is the end of this lesson. Thank you very much for watching. Keep watching and try to get better at your mathematics. See you in the next video on inverse function, the use of algebraic processing to determine the inverse of a function. Bye.